Hello there, Mr. Sutton bringing you these AB Calculus 6-3 classwork solutions on slope fields. For this problem, I'm trying to pick a differential equation that matches this slope field. So let me test out a few points off of this slope field and see if these answer choices give me the same thing. I'm going to start with the point 3, negative 3 all the way down here. Not sure exactly what it is, but it looks pretty positive. So let me test out 3, negative 3 in my answer choices. So right here we've got 3 over negative 3, which is going to give us a negative answer for choice A. So we can eliminate A. For B, we've got 3 squared over negative 3 squared, which essentially comes out to 1. That's positive. If I'm being honest, this doesn't look like a slope of 1, but whatever. Maybe we can cross it off later on. For this one, we've got, this is going to be 3 cubed over negative 3. That's a negative, so we can definitely eliminate C. For choice D, we've got a positive over a negative, so that comes out negative. We can eliminate D. And finally, choice E, we've got a positive over a positive if we square the negative 3. So at the end of the day, it looks like A, C, and D can all be eliminated. That means we're narrowing it down between choices B and E. And if we're being honest, choice B does not look very likely. This does not look like a slope of 1. But let's test one more point just to be absolutely sure. So if I test out negative 3, 3, so that's over here. That's a negative slope off our slope field. Testing that out, B is still going to come out positive because we're squaring both things. So we can eliminate B off of that. Choice E is going to come out negative because now we're doing an odd exponent on the negative portion here. So then definitely choice E is what we're looking for. On this problem, we're trying to match this differential equation with one of these slope fields. So I'm going to start by testing out a point in this differential equation to see what slope it gives me, and then I'll see if the matching point on the slope fields here matches that. I'm going to start with the point 0, 0. I mean, why make it harder than I need to? If I plug that into my differential equation, I've got 0 squared minus 1, which is negative 1. So let's see what I can eliminate based off of that. Choice A, that's at least negative at the origin, and you have to kind of squint to see these. There's very tiny slope lines. Choice B also has negative slope at 0, 0. So A and B are still in the running. Choice, let's see, I guess we'll skip to choice E because it's there. Choice E is not defined at all at the origin. And it looks like the same thing with choice D, not defined at all. Choice C looks to have a positive slope at the origin. So then choices C, D, and E don't match up with what we found with this original differential equation. Let's test one more point now. It's down to A versus B. I'm going to test the point 0, 1. So here I'm going to be doing 1 squared minus 1, which is 0. So looking at A at the point 0, 1, that looks like a slope of 0 if you look closely. Choice B, this is clearly not 0. This is sloping down at 0, 1. So B is definitely eliminated after that one, which means choice A wins. On this problem, I'm trying to match this differential equation with the correct slope field. So let me test a couple points and see what we get. I'm going to start with testing the point negative 1, negative 1 in here. So if we test those out, I end up with a positive number from this differential equation. Positive 2 to be precise, but let's see if we can at least narrow it down with the positive negative thing. Choice A, if I look at negative 1, that's a negative slope down there, so A is gone. Choice B, at negative 1, we have a positive slope, so B hangs around for a little bit longer. C, negative, the scale is different on C. This is right here. This is negative 1, negative 1. It's kind of weird. Or no, this is 0.5. So anyway, these are all negative. So this is not going to work out for us. And then choice D, it looks like negative 1 is a positive slope, a very positive slope, but positive nonetheless. So we're just going to eliminate A and C for now, and we'll test something out so we can be sure about picking B versus D. All right. So next I'm going to test out 0, 1, which if I plug it in here also gives me a positive slope. Checking out B now at 0, 1, we definitely have a positive slope there. For D at 0, 1, this looks to be a slope of 0. So we're going to eliminate D on that one, which means choice B is our answer. For this problem, we're given a slope field for a differential equation, and y is the particular solution through the point -1, 2. Based off of that, we want to know what h prime of -1 is if the h function is 3x times f of x. All right. In order to find h prime of anything, it would be helpful if I had some sense of what h prime even looked like. This is a product of two functions, so h prime of x is going to use the product rule. And for that, I'm going to get my box and ribbon to help me out. So here's my box. Up here, I've got 3x and f of x, whose slopes, whose derivatives are 3 and f prime of x. All right, so at this point, I'm going to plug in -1 to all of these. So if x equals -1, let's see what we have now for these values. 3 times -1 is -3, so that's pretty easy. F of -1, well, what could that be? If you look here, they said that this differential equation has a particular solution through the point -1, 2. This is their way of telling you that f of -1 equals 2. So 2 then is f of -1. And now 3 playing itself in this motion picture. And finally, f prime of -1. Well, how do we find that? This is a graph essentially of f prime. At least it's a slope field. It's not a graph of f prime specifically, but it gives you the slope of f at any point that you could possibly desire. So f prime of -1, that's going to require us to plug in -1. But to read this graph, you actually need a y value too. Since the y value at -1 is 2, we need to look at the point -1, 2 on this slope field. And that'll tell us the actual value of f prime of -1. So -1, 2 is right up here. This looks to be like a slope of -2 if you count the squares. So we're going to put -2 for that value. All right, now we do the ribbon to multiply these together. So we've got h prime of -1 equals 3 times 2. And then we've got -3 times -2. So this is 6 plus 6, which is 12, giving us choice E. For this problem, we want to match this slope field with one of these differential equations. Let me test a few points and see what matches what. So in my slope field, I'm going to look up the derivative at -1, 1. So let's see here. This is -1 here. This is 1 up here, just looking at our scale. That's a slope of 0. Let me see what gives me 0 from these answer choices. So this is -1 times 1, which is not 0, so A is gone. This is -1 times 1 minus 1, so -1 minus 1 does not give me 0. B is gone. Here we have -1 plus 1. C works. C gives us 0. Here we have, let's see, -1 minus 1, which is not going to work out, so D is gone. And here we have -1 plus 1, which is 0. Cubed is still 0. So it looks like C and E are still in the running. A, B, and D are all eliminated. All right, to pick between C and D, let's choose another point. I happen to test out the point 0, 0. It's a pretty easy one to test. We can clearly see here that the slope at 0, 0 is 0 based off the slope field. So plugging that in to choice C, everything is just 0, so all of that comes out to what we expect or hoped for. In choice E, the only other one in the running, this is going to be 1 cubed, which is not 0. So E is eliminated then, which means choice C is our answer. On this problem, I've got a slope field for this differential equation, and they're telling us that G is the solution to this differential equation with an initial condition of -2, -1. Based off of this, they want to know the limit as x approaches infinity of g of x. Well, it would help if we knew what g of x looked like. Since we have the slope field and an initial condition, let's start at the point -2, -1, and then just follow the tangent lines. So if we do that, we're going to see that we're approaching the x-axis like this. And since we're approaching the x-axis, it kind of looks like we've got an asymptote going on if we follow those tangent lines. So which answer choice would match up with this? 0 is the best choice out of these. Certainly not negative infinity or -2. -2 is down here. 2 is up here. That's at least a horizontal asymptote, but there's no way this function is going to get up there going at this rate. And then 3 is just totally off in left field. So C it is. For this problem, we want to graph the slope field for this differential equation. Let me start by making a table of values so I can kind of map out what my slopes look like. So I'm going from -1 to 1 on the x values, and on y values I'm going from -2 to 2, but I'm skipping 0 because if you divide by 0 here, that's going to be undefined. All right, so plugging all these in, I've got an x value of -1 to start with, so this is -2 times -1, or 2 over whatever these y values are. So 2 over 2 is going to give us 1. 2 over 1 is 2. 2 over -1 is -2. And 2 over -2 is -1. Next, we have an x value of 0. That's going to zero out everything. So I'm just going to write zeros all the way down. Next, we have an x value of +1. So the only difference between this first column and this one is the sign is going to be different, because now we're multiplying by +1 instead of -1. So we're just going to reverse all the signs in this first column. So -1, -2, 2, and 1. All right, time to graph these out. Up here rather, at -1, 2, we've got a slope of 1. Then we have a slope of 2, so a little bit steeper. Down here we have a slope of -2 and -1. This next one we have slopes of 0 all the way down. And this one we have kind of the symmetrical slopes to this side. So -1, -2, +2, and +1. Here's +2, +1. There we go. For this problem, the first part of it anyway, we want to graph this differential equation in a slope field. We've got 12 points to take care of. I'm going to make a table to organize the information. So my x values, I'm going from negative to +1. Y values, I'm going from 0 to 3. So for the x value -1, we're essentially doing -1 squared, which is just 1, which makes no difference whatsoever. So really, we're just doing y minus 1 for this first column. So we've got 3 minus 1, which is 2. 2 minus 1 is 1. 1 minus 1 is 0. 0 minus 1 is -1. For this next one, it's even easier because we're doing 0 squared, which zeroes everything out. So this whole column is just 0. And this next one, we're doing 1 squared instead of -1 squared. So nothing else changes from this first row because negative and +1 give you the same thing when you square them. So I'm just going to copy this first column in this last column. Mapping out my slopes now, or drawing them, I've got 2 up here. And this is going to be a slope of 1, 0, -1. This next whole column here is all zeros, so all horizontal lines. And this last column is a complete copy of this first column. So we got 2, 1, 0, and -1. For this part of the problem, they basically want us to describe all the points in the xy plane where the slopes are positive. And we can't just rely on the slope field because we have to consider all the points, including the ones in between what we graphed here. So that means we have to actually look at the differential equation and analyze that. All right, so taking a look at the x's, since those are being squared, if x is not 0, then x is not going to affect the sign of the slope. Because x is always going to give you something positive when all is said and done, unless the x value is 0. So really then, as long as x does not equal 0, it all comes down to this y minus 1 factor. So our whole slope is going to be positive if x is not 0 and y minus 1 is greater than 0. So putting all that together, we can say our slope is positive if y is greater than +1 and x does not equal 0.